going through a bunch of sample problems, review really on hydraulics, and I do want you, I'm going to do a question, I'm going to ask you to do another one. That's all going to be part of your submission, okay, with your, when you hand in your package at the end of the unit on December 19th. But yeah, I'll do a question with you, and then you can right away do the next one. If you want to just pause the tape, or you can watch the whole video and do the questions later. I'll leave that to you. But first, going back to the beginning of the unit, determine density of a textbook. So we know the dimensions of the textbook, and we know the mass. And what you should know is that volume, a textbook's going to be rectangular prism, so the volume is just going to be, you know, you multiply everything together. Okay? And then you say, okay, density is mass over volume, so you just do the divide, and that's the kilograms per centimeters cubed. Okay, that volume will be centimeters cubed, so it's centimeters times centimeters times centimeters. So pretty easy. You can try this one. Oh, this is an identify the metal. So you're going to find the density, and then I want you to look up, use the internet on a table of densities to determine what you think that metal is. Okay, so you can do that now if you want to pause, or go ahead and watch the rest of the video first. Pressure. Homer has a mass of 125 kilograms, and the dimensions of each of his feet are about 33 centimeters by 22 centimeters. Determine the pressure he exerts on the earth. Okay, so first thing, pressure, because generally measured in pascals, you should have your area in meters squared. So I took the 33 centimeters and I made it 0.33. What many kids do, and it is a mistake, is they go 33 centimeters by 22 centimeters, they get whatever area that is, and they say, okay, I'll divide by 100 to get meters squared. I just want to show you something. We'll do this here. You know, area conversion, centimeters squared to meters squared. So say you had, well, yeah, okay, do that. Say you had 100 centimeters squared. You're going to say, okay, I'm going to turn that into meters, and I'm going to say 100 centimeters squared must be, oopsie, it must be 1 meter squared. And let's see. There it is. It's 0.01. Okay? It's not divided by 100. It's divided by 100 twice. And the reason is that, you know, each time you change centimeters to meters, you're dividing by 100. So that really means when you're doing area, you're dividing by 100 twice. So if you were to do this question, and you did the area first by 33, which is 33 times 22, and got that number in centimeters squared, divide by 100 twice is the quick answer. To be sure, come to one of these unit converters and put your number in here and find out. Do not divide by 100, because it's not divided by 100, okay? Anyway, here's the answer, though. So pressure is force of gravity divided by area. We're going to use meters squared, of course. So if you look at my calculation, I said, okay, there's the mass times 9.8. That's the force of gravity. And then I put those in meters, 0.22 by 0.33, multiplied by 2 at the bottom there, because the total area, 2 feet. Right? And you get the pressure. Okay? The next question, if you do that, when you do this one, the kids always have a hard time with this one. We're talking about someone walking on their stilettos, tiny little model on her stilettos. You know, you have to figure out the right area. Again, you're going to put these into meters, right, to do the calculation. There's the answer, and kids have a hard time getting the right answer. There's so many steps in getting the right. But just remember, there's, you know, make sure you get the right answer, 1 foot, then multiply it by 2 to get 2 feet. Make sure it's in meters squared, and use a unit converter if you're not sure. And yeah, it's not that hard, but kids often make mistakes on it. Next, hydroforming. So we have a huge force applied to a piece of steel with that surface area. Determine the pressure. Again, I'm given centimeters. I need to put it into meters. So force divided by area. Whoopsie. Don't look at that one. That's yours. That's yours, not mine. So you have the force and then another area down here. It's, a rectangle. So again, 0.42 by 0.28. Okay, figure what that is. It's a huge number in pascals. Divide by 1,000, 8 kilopascals, and that's it. You can, mind you, if you give me your answers in pascals, I'm fine with that. It just depends on what you're trying to compare it to. Okay, water jet cutting process. You have a stream of water, you've got a speed, so that's little v, drills with a hole of radius 0.75. I'm going to have to divide that by 1,000 to get to meters, and I'm given a force, and I know a time, so I need to find all those things out. So in part A, I got to get the pressure. So first we're given the force, that's easy. The area is pi times this number divided by 1,000, right? 0.00075 squared, that's the r squared. And then whatever answer I got here, I divided by 1,000 again, just to get it into this number. Okay, again, you can, it says in kPa, yep. So you have to divide by 1,000 again. If it specifically says kPa, take your answer from this and divide by 1,000, which is what I did. Volume flow rate of water, that's little q. Okay. Find a formula for little q, and it's speed times area. So the area again is just this area, and speed is given in the question. So there's the volume flow rate. And total volume is QD. Okay, so we're given time at 24 seconds. We've got our volume flow rate. You just multiply. So number 8 you'll do on your own. Number 9, we're given gauge pressure, and the atmospheric is 101. Calculate the absolute. Pretty easy. Just make sure you have the same units. Add them, nothing to it. Same kind of question right here, except for this one you're looking for gauge pressure, so you're looking for the PG in the one you're going to do on your own. Number 11, vacuum pump removes air from one side of the manometer that uses mercury, so there's our density. The other side of the manometer is open to atmosphere, and we have a static pressure head, which is little h, of 0.5. Okay, so we're looking for gauge pressure. So we're given density, we're given h. Gauge pressure is just going to be dgh. Okay. And that says, there's the atmospheric, what's the absolute? So then you just use this equation here. Make sure when you're doing this equation that you're using everything in the same units. They're both in kPas. Okay. Okay. Number 13, the maximum depth recorded for a deep sea dive is 308 meters. Assuming the density of seawater is a little greater than, that's 1,030. Oh, I didn't even put down the units, but that'll be kilogram per meter cubed. And the atmospheric pressure is 101 kPa, determine gauge and absolute. So gauge pressure is dgh. So we're given the density, we're given the h. Just multiply it out. And then to get the absolute pressure, you add that to 101. So there's the absolute pressure. Okay. Okay, this one, I just wanted to make sure you noted the correction. My answer is incorrect. So make sure you cross out my answer, and when you do it, that's the answer you should be looking for. Pascal's law. So here we have a small piston, 0.12 meters squared, a large piston of 0.89, and we're given Fs, force on the small piston. So first determine the pressure. So actually that step is just Fs divided by As. Okay? And then it says determine the magnitude of the force on the large piston, so FL. So you use this equation here, which hopefully you have on your formula sheet by now. And determine the maximum mass the large piston can raise. So here you'll use, if you know FL, it's going to be mlg. So you solve for ml. And that's it. There's the answer. So that little piston can only lift 50 kilograms. Not a great answer, but small. Okay. Here's a great question. I love this question. Why does a curved ball curve? And this is Bernoulli's principle, and it's pretty cool. But what you have to think about, my little drawn description, and of course on your own I'll get you to describe why a ski jumper stays in the air so long using Bernoulli's principle. But with the curved ball, what the pitcher does is they throw the ball, and of course it has a rotation on it. So that rotation will cause air to travel with it, right? As the ball spins, it's moving into wind resistance. And while the wind resistance on either side of the ball would be the same, because of the rotation of the ball, because of the spin on the ball, then you've got sort of an extra, you have added speed of air on one side compared to the other. Just basically there's more air on this side, so it's traveling at a higher speed. So because of the higher speed, then the ball, this will have lower pressure on this side and higher pressure where there's lower speed. And because of that, the ball will curve into the lower pressure. And that's how a curved ball curves. So use that same idea of Bernoulli's principle, the airplane lift, and everything else to think about the ski jumper here. Okay, and that's it. That's the last video I've got for you. That's it. And hopefully you'll have lots of time now to get all your stuff done, your booklet ready to hand in before you leave for Christmas holidays.